All right, guys, this is the review for unit test number 3. Just a couple things. It's not going to do you any good just to get the answers from here. If all you're doing is watching it and copying the notes and the answers, you're probably not going to do real well on the test. I would encourage you to do the problems, try the problems first, and then check over the explanation and the answers to see if you've done it correctly. So if you're just using this to copy the notes and the answers, you're going to want to go through the test review a second time and do it all by yourself without looking at the notes. Otherwise, you probably won't perform real well in the test. So let's go ahead and get started and run through these problems pretty quickly. As always, if you have questions that this video does not address or you think there is a mistake, please let me know in class. So all we're doing on number 1 and number 2, we're finding f of g of x. We haven't used this notation a lot, but that f, little circle x, is the same thing as f of g of x. So that's what we're doing on number 1 and number 2. We're finding g of f of x. So in this problem, instead of negative 2x plus 1, it's going to be negative 2 times x squared plus 2 plus 1. So all of this is just being substituted in for x, and then just distribute the negative 2 and combine your like terms. So our answer to this first one is negative 2x squared minus 3. And there is a space over here for you to put all your answers. And the format of this review is very similar to the format of your test. Part B, we're finding g of f of x. So instead of x squared plus 2, it's going to be negative 2x plus 1, all of that squared, and then plus 2. So squaring negative 2x plus 1. Again, I'm going to skip some steps here, but this is just FOIL method or box method or distributive property. So everything in this parenthesis gets multiplied by everything in there. And there's the work for the second part of number 1. Again, we're just doing the double distributive property here for box or FOIL. And then don't forget about this plus 2. A lot of you on the quiz, if you missed something, you forgot to add on that plus 2 at the end. Don't forget to add on that plus 2 at the end. If we're moving too fast, pause the video. Make sure you get all the answers before we move forward. So 2 and 3, we've got the same thing. First, we're going to find f of g of x. Instead of 1/3 x minus 2, it's going to be 1/3 times 2x plus 3 minus 2. I would encourage you, if you're doing it in a calculator, 1/3 times 2x is 2/3 x. I would avoid using a decimal because that decimal, if you put in the calculator, that's a repeating decimal, and we want to avoid those. And then 1/3 times 3, those are just reciprocals, so they leave us with 1. We just combine our like terms. So for 2a, we get 2/3 x minus 1, because 1 minus 2 is negative 1. Then we just go the reverse way. G of f of x, that's 2 times the third of x minus 2. And don't forget the plus 3 at the end. We're going to, I believe, get a pretty similar answer here, which is really more just for coincidence. 2 times 1/3 x is 2/3 x. 2 times negative 2 is negative 4. Again, this video more to check your answer than to show you the step-by-step process. So pause it. If it's going too fast for you, pause it, do it on your own, and then check if you want to be successful on this test. So we get 2/3 x minus 1 on both. And again, that's just a coincidence. That doesn't tell us those are inverses. It has to equal x for them to be inverses, if you're wondering in that. Number 3. So the first part of 3 is not bad. Instead of x minus 1, it's going to be x to the third minus 2 minus 1. So we just combine our like terms. Negative 2 minus 1 is negative 3. So our answer to this one is x to the third minus 3. G of f of x is a little uglier on this one. So we're going to insert x minus 1 in for x. Yeah, we do have to cube x minus 1. So that's going to be x minus 1 times x minus 1 times x minus 1. Again, if you're really clear on the test and you show all your work and it's neat and easy to read, you can get a lot of partial credit because it's easy to make a little mistake on this problem. But show your work on the test, make it neat so it's easy to follow. You can get partial credit if you do make a minor arithmetic mistake. So when we do x minus 1 times itself, the ultimate answer will be x squared minus 2x plus 1. Again, I'm skipping some steps in my multiplication. So if you're using box method, I did skip the step where I just combined the negative 2x's here. But then we need to multiply that result by x minus 1 one more time because it was x minus 1 to the third power. So once again, do the distributive property. So x squared times x. And we're going to distribute the negative 2x. And we're going to distribute the positive 1. And again, don't forget about this minus 2 to combine like terms at the end. So combine like terms and you'll get your answer for 3b. X to the third has no like terms. We have negative 3x to the second. Negative 1 minus 2 is negative 3. We have plus 3x minus 3. All right, 4 and 5 are considerably shorter because instead of in terms of x, number 4 wants it in terms of negative 2. So what that means is f of g of x is going to be, let me just move my recorder out of the way. Instead of x squared minus 3, it's going to be x plus 5 squared minus 3. And instead of doing all that math and multiplying x plus 5 times itself, we can just insert that negative 2 in for x right now. And that's what I would encourage you to do right now. And a couple options. You could just type all of this in the calculator at once to get the correct answer, or you could take it piece by piece, however you like. But ultimately, your answer to this one, I believe, should be six. Negative 2 plus 5 is 3. 3 squared is 9. Minus 3 is 6. So there's your answer to 4. Number 5, we're just going the other way. We're starting with the g function, x plus 5, and we're inserting x squared minus 3. So instead of x plus 5, it's x squared minus 3 plus 5. And instead of x, we want it in terms of 4. So we're going to insert a 4 for x. I don't really have to have the parentheses, that red parentheses I had. I don't really have to have that in that case. And again, to get the answer, make sure 4 is in parentheses. Type that in. Answer should be, what, 18, I believe. All right, 6 through 9, again, it's just basic arithmetic, so just be careful, show your work, Number 6, we are subtracting the two functions. So it's going to be x squared minus 5 minus 2x minus 7. So this negative sign is being distributed into the second parenthesis. So this is going to be x squared minus 5 minus 2x plus 7. Combine your like terms. There's your answer. X squared minus 2x plus 2. Because that's a negative 5 and a positive 7, which gives us positive 2. Number 7, we're multiplying x squared plus 5 times 2x minus 7. Box method, FOIL method, distributive property, whichever method you prefer. Practice that. Again, don't wait just for the answer. Make sure you can do it on your own and just use this to check. Actually, that's the answer because there's no like terms. No like terms, so we're done. All right, number 8. Most of you, I'd say probably about 80–90% of you got this one right on the quiz. If you didn't get it right, don't know why. Make sure you ask me. But we're just dividing function f by function g, but instead of x, we're inserting a -1. And this is the one I would be careful and not do it all in the calculator at once. Figure out what the numerator is first. So I would just type in that top part there without the fraction part. Just type in -1 in parentheses squared plus 5. That should be 6. And then type in the bottom separately. 2 times -1 minus 7 should be -9. And then reduce 6 over -9 to -2/3. You can reduce that in your head or reduce that in the calculator with math. Enter, enter. That's how you do number 8. All right, finally, number 9. I'm going to erase 8 here, so I have room for number 9. So number 9, we're just adding the f and g function together. Instead of x, we want in terms of 5. There's different ways to do this, but in this particular problem, I think it's easier to actually combine like terms first. I think you're less likely to make a mistake if you combine like terms, and then we substitute the 5, parentheses 5, everywhere you see an x. And then just evaluate it. You can type all this in the calculator exactly like it looks, as long as you have the parentheses. That should ultimately be 25 plus 10, I believe 33 should be your answer. All right, moving to the next problem. All right, number 10. There's one question like this on the test. We didn't do a lot of this in class, but essentially we're just working the first few problems backwards here. They give us f of g of x. They want us to come up with a function for f of x and a function for g of x. So essentially this one we're starting with the function f of x. I would encourage you to try this one on your own first, because there's actually a lot of different correct answers. If you think you may have a correct answer that differs from mine, let me know. But an easy way to do this one is call f of x. Just call f of x the square root of x. And think about what we would have to substitute in for this x right here to get that composition of functions. And all we would have to have g of x be is x minus 3. So now, if I asked you to find f of g of x, that would just be take x minus 3 and insert it in for x, which is the square root of x minus 3, which is what we wanted right here. So this is ultimately our answer right here. It just wanted us to find an f of x and a g of x that could result in that composition of functions. All right, 11 and 12. We've done a lot of these the last week or so. Determine whether each pair of functions are inverses, and they specifically want us to do it by composition of functions. So you do have to follow the instructions and use that method to determine whether those functions are inverses. So to do that, we need f of g of x and g of f of x. The end result has to equal an x, and if that occurs, they're inverses. So f of g of x would look like this. Most of you, I think the setup is no problem. Algebra, a little tricky here. So 2 times x over 2 is just x, because the 2's cancel. And then 2 times negative 5 is negative 10. We have to distribute that 2 to both of those terms. And then don't forget, we do have a plus 5 that's not being multiplied by anything. So x minus 10 plus 5 is x minus 5. So that doesn't end with an x. I think on the quiz it asked for you to find both. This one doesn't specify for you to do both f of x and g of f of x. So we can stop right here and say these are not inverses. So that's the answer to 11. And then let's do 12 the same way. Again, set it up. The negative 3 and the positive 3 just cancel. And before you take the square root of anything, get rid of your like terms. So now we can take the square root of x squared. Of course, the square root of x squared is x. And then let's go the reverse way to see if both are true. On the test, you would have to check both. If one is equal to x, you need to check the other one to get full credit for that problem. Instead of x squared minus 3, it's the square root of x plus 3 squared, and minus 3. And we're not actually really squaring anything, because square roots and raising it to the second power are opposite operations, so they cancel. So we don't actually have to take the square root of anything, and our end result is again an x. So they are inverses. On the test, I believe there will be a blank for you to put that answer, but just make sure your answers are circled or in an appropriate box, just so I don't have to hunt for your answer. Just makes it easier on me, and is more likely you're going to get full credit for that problem if you have an answer that's clear. All right, so for the next few problems, for number 13, it wants you to find the inverse of each function. So that's the first thing you need to do. And then list the domain and range of just the inverse. So find the inverse first. So that involves switching the x and the y. Probably hear my dog playing in the background. But solve for y, so we're going to get 6y equals x plus 1. And then divide everything by 6. So for those that always forget to write the inverse symbol, notice it is written here for you. So if you put the answer in the right place, you don't have to worry about messing that up here on the review. If they don't have that symbol in the test, make sure you write it, since that we are talking about the inverse. Then find the domain and range. We talked about this the other day in class. The easiest way is just to put this in your calculator. Put it in y equals. Most of you found it pretty easy to find the domain and range once you put it in y equals and graphed it. And I will tell you, if you put it in y equals, you want to make sure you have a parenthesis around x plus 1. So the calculator knows you're dividing all of x plus 1 by 6. But the domain and range for this function, because it is a line, and it's not vertical, it's not horizontal. Pretty much any line that's going to be diagonal, it's going to be all real numbers for the domain and range. All right, a couple more. Try 14. I'm going to ask for you to pause it. I'm going to skip ahead in the work on number 14. So pause it now. Try it on your own, and you can check in here in just a minute. So you switch the x and the y. The first algebraic step should be to multiply both sides by 5, because this eliminates the fraction on the right-hand side and makes this problem much easier to solve. So there's your answer to 14. This is number 14. And again, you can check the domain and range by graphing it in y equals. Again, this is just a diagonal line. Domain and range for this function should be all real numbers. So I, for some reason, don't have a number 15, so I'm going to skip ahead to number 16 and do this one. First step to solve this one for y is to eliminate that exponent of 2. And anytime we want to eliminate a square root symbol, we just square root both sides. And that square root and that exponent, they're opposite operations. It's like dividing and multiplying, two different operations. Subtract 4. That 4, since we're subtracting 4, we've already square rooted both sides. That 4 does not go underneath the square root symbol. Does not go underneath. So our inverse is the square root of x minus 4 on the outside. We get points deducted, obviously, if the minus 4 is underneath. Find the domain and range. Again, put it in the graphing calculator to identify how far it's going left and right and how far it's going up and down. Have you pause it. See if you can do it on your own first, then I'll show you the answer. So real quick sketch of that graph. It looks something like what I've got there. The domain is the x values, the left and right of the function. the farthest left it goes is right there, and that value for x at that point is 0, and then it goes to the right continuously. It goes from 0 to infinity. The range is the lowest point that it goes to. The lowest point that it goes to is right there. So the range smallest value is -4. And if you can't see it real clearly on the calculator, use that to help you make an educated guess at that lowest point. And it doesn't necessarily look like it, but it is going up. It's going up very slowly, but if we continue that graph out to the right, it would keep going up forever and ever. So that's your answer for the range. All right, finally, 18, it says 17 and 18, but 18 and 19 and 20, just a few graphing problems. Essentially what we want to do is we want to pick points off this graph that we know the coordinates of, and we just want to flip-flop them. So the 3 points I have graphed in red are right over here. And remember, to find the inverse function, we're just going to flip-flop the x's and the y's. And we flip-flop the x and the y's. 2 of those points stay the same. So -1, -1 stays the same, and -2, -2 stays the same. Point that differs is the point 0, 2, which goes right there. And then graph a sketch of the inverse function. And sketch the inverse function should look something like that. I missed my point just a little bit. Make the point a little bigger. That's the answer right there. You don't have to do anything more once you get that. But again, we talked a lot about this. It's the inverse. Essentially, the way to double check is, are those lines symmetrical about y equals x? That purple line I just drew? Yes. That purple line, y equals x, is the line of symmetry of those two graphs. Same thing on number 19. Pick as many points as possible that you can pick off the graph. Pick as many points as possible. Never hurts to do a couple more than you need to. So those are all of the points that I've picked. Write down the ordered pairs, flip-flop them, and then graph the new points to find the inverse of that function. So those are the original points I have. I flip-flopped them to find the points of the inverse function. So just graph the points of the inverse function. All right, so what I've drawn in black, there's the inverse function. That would be your answer, but just one more time, just to show you, those two functions are symmetrical about the line y equals x. So that proves they're inverses. It's a good way to check your answer. If it doesn't look symmetrical by that line, you may have made a graphing mistake. All right, last but not least, number 19. It says graph the given function and its inverse, and also write the inverse equation. So there's a lot of different ways to do this. You could find the inverse first and then graph both those equations. The way I might do it, maybe the easiest way, substitute this into y equals in your calculator and get several whole number points that line falls on. So go to y equals, insert it, and look at the table for the graph and graph those points. So those are the points I've picked for the line y equals 2/3 x - 1. 2/3 x - 1, 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 crooked. And I've got those points listed right here. We can just find those in the calculator. The inverse points, we're just going to flip-flop the x and the y, and I'm going to graph those points. So that's the inverse graph right there. The inverse graph is in red. The original function is in black. The last thing it wants us to write the equation of the inverse line. And you could do that just by switching out the x and the y and solving this original function. Or you can do what we've talked about the last unit and write the red equation in slope-intercept form, where slope-intercept form is y equals mx plus b. The slope of this line is up 3 over 2. The slope is y equals 3 over 2x. That slope is 3 over 2. And the y-intercept, so y equals 3 over 2x plus 3 over 2. It's important to note that these 3 over 2's could also be 1.5's. To get this number, I actually did go back and found the inverse of this function by switching out the x and the y, then just solving it for y. If you have any questions, let me know. Number 20, you can just do for extra credit if you feel up to doing that problem. But that's it. Let me know if you have any questions. The test is coming up in a couple of days. Make sure you study this. Do this again before Friday. If you don't look at this again before Friday, you probably won't do real well on the test. Good luck.